Welcome to Power Protection Basics by Orion Power Systems. What we're going to talk about here is UPS system basics and how to protect your systems from power problems. The first thing I'd like to talk about is the different type of waveforms that you get. This is alternating current, just what comes out of your outlet. Essentially, there's three different types. There's a true sine wave, which is like what you get from the utility. The next one is a square wave, and that's really what you get from a camping inverter or an automotive inverter, something like that. And then the third one is a step square wave, and that's much cleaner than a square wave, and that's similar to what you would get in a department store type UPS. What type of waveform do you need? It really depends on the application. You almost never want a square wave. That can really damage equipment if you run on it long term. Essentially, the dirtier the power, the more heat it produces, and heat kills electronics. So a step square wave is fine for a lower cost piece of equipment like a PC, and you don't want to run on it for a long time, generally more than 10 or 15 minutes at a time whenever you have an outage. And a sine wave is the ideal power output waveform, and more of the high quality UPS systems use that type. Now let's talk about watts, volts, and amps. Essentially, this is the most basic formula that you will use when you're dealing with anything electrical. So basically, it's an inverse relationship. And what you'll see here is in the example below that if you are wanting to produce 1,000 watts, you could have 500 volts times 2 amps, and that would give you 1,000 watts. Or you can have 1,000 watts produced by 2 volts times 500 amps. You end up with 1,000 watts in both cases, but the larger amount of your amps, the more copper you need, because you have to have a bigger wire to run the electricity through it. And as expensive as copper is, that's essentially why when you see pieces of equipment that use higher wattage, they will go with a higher voltage, so you don't end up with a wire the size of a fire hose. And it's really just all about cost. So, for example, anytime you go over 6,000 watts in UPS systems, they're almost always going to be 208 or 220 volts. So next, let's talk about single-phase wiring. And this is essentially like the wiring that's in your home. And this is really just to give you a little bit of background in wiring. So if you could imagine this right here, this is the transformer on the outside of a home, and it'd be coming in from the power company at 480 volts. And if you could imagine, this is the electrical box in your house. And what you have is, a lot of times it's called split phase voltage. But what you have is a hot wire, a neutral wire, and another hot wire. And if you could imagine snapping a breaker in to your breaker box from hot wire to hot wire, you'll have 240 volts. And if you put the breaker in from the neutral to the hot wire, that will give you 120 volts. So this is it's very common in small offices, residences, and even in some commercial buildings, they will have single-phase panels. One other thing I wanted to point out is when you think about surge protection, a lot of the time people think of surge protection as it's going to block a surge coming in. Well, actually, the way that most surge protectors work is they use a device called a metal oxide varistor, or an MOV. And it basically connects from the hot wire to the ground wire. And when a large surge comes in, instead of trying to block it, it actually diverts it to the ground wire, and then it dissipates into the grounding network of the building. So that's essentially how surge protection works, and that's how the surge protectors that are built into the Orion Power UPS systems work. They don't try to block the surge, they divert it to ground. So the next one I want to show you, and this is really more for just familiarity. This is three-phase wiring, and this is what you'll see in a lot of commercial buildings. And essentially what you'll see, for example, in a data center, you'll see 480 volts coming into the building, and then they will use a transformer to step it down to 120, 208. And that's the most common voltage you see in data centers. And this is actually called 120Y208. And it's the same situation here, where if you could imagine this being the electrical panel, you would put a breaker in from hot to neutral, you would get 120 volts. And if you put the breaker in against hot to hot, you would get 208 volts. So again, it's the same thing, but this is really more just for familiarity. Now, what I'd like to talk about is there's really two different ways to install a UPS system. And essentially, you can do plugs and receptacles, or you can do hardwired. So basically, we're going to talk about plugs and receptacles here real quick. It follows the NEMA convention, which is the National Electrical Manufacturers Association. And it's a code, and basically what the code means is, for example, a NEMA 515, which is what is in most people's homes, the 5 stands for 120 volts, the 15 is for 15 amps, and the R is for receptacle. And so that's this plug here, plug and receptacle. If you're dealing with 208 volts, you could, for example, have the L630, which is this one right here, and that's L for locking. 6 is 208 or 240 volts. 30 is 30 amps, and P is in plug. And this chart is actually in the Orion catalog, so that will help you diagnose any plugs that you might run across. Now, the other way that you can install a UPS is a hardwired installation. And essentially, hardwired just means it's plugged in or it's wired directly into the building. And the way it's generally done is you have an input panel to the UPS. A lot of times it's called a building service panel. And this wires into the UPS. And then on the UPS, you have a bypass switch. And then you come out of the UPS to what's called a load distribution panel or a critical load panel. So normally this is done with UPS systems that are 6 kVA and above. Sometimes it's done with smaller ones and controls applications, but normally it's for 6 kVA and above. And one thing that you always want to make sure of is that you have a maintenance bypass switch, because if the UPS ever fails, you need to be able to get power to your equipment quickly. And if you don't have that, you would have to call an electrician and have him come out and wire around the UPS. Whereas if you have the bypass switch, you just throw the switch and you immediately have power back to your equipment. But if you have equipment or computers that are spread all over the building, hardwired is definitely the way to go. It does have to be done by a licensed electrician. Okay, now let's talk about the most common power problems. Essentially, the ones that are seen most often are surges, blackouts, brownouts, overvoltage, and line noise. And essentially, the best way to protect your equipment from that is a UPS system. They protect against all of these problems. Some of them do a better job than others. And right now, I'm going to talk about the different types of UPS systems and just give you a good background in that. Essentially, the most basic UPS system is the standby. And the standby, the Orion product that meets that spec is the Office Max. And basically what it does is you get power coming in from the utility, and it watches the power come through, and if it goes outside of that range, it throws a high-speed switch and runs off a battery and then powers your load. And if it goes back in the range, it switches back to utility power. So it's a very basic design, but for workstations and less critical loads, that's a great way to go. The biggest flaw with this design is that if you have a prolonged brownout or overvoltage, it will switch on the battery and then run until the battery gives out, and then it will drop the load. So that's the only really issue with that particular design. The next one is a line interactive UPS. And essentially what a line interactive UPS does is it's the same design as a standby, except it uses a tap switching transformer. And what that does is that regulates the voltage. So this unit again watches the power come through. The tap switching transformer tries to correct for it, but if it can't, then it throws the high-speed switch and runs off a battery where it converts DC, which is battery power, into AC power, and then powers the load. The great thing about this, if you do have a brownout or a overvoltage that's long-term, it can actually use the tap switching transformer to correct for that voltage without using the battery. So that's a line interactive design. Now, one other point I wanted to make is that those are, some of them output a step square wave, and some of them are a true sine wave. It just depends on the model, so that's one thing you'd want to check on. The last design we're going to talk about is the double conversion UPS. This is the most robust design, gives you by far the best power quality. These systems, essentially how they work, and the reason they're called double conversion, is they bring in the utility power, they convert from AC power or wall power to DC or battery power, and then the battery is wired in parallel, and then it converts from DC power to AC power and then powers the load. So essentially, it creates its own power with the inverter at all times. So because it's running off the inverter at all times, it has to output a true sine wave. The voltage regulation is plus or minus 3% or better. And one other thing this design has is an automatic bypass switch. And so if any of these components fail, it automatically routes power around the internal components and powers the load. So there's a lot of really neat things that it can do. Just to give you a quick example, the voltage regulation on this unit is plus or minus 3%. The line interactives and standbys are plus or minus 10 to 15%. So it's a pretty big difference. One other quick thing is, since the battery is wired in parallel, there's no transfer time when the power goes out. It's a seamless transition from being powered from the rectifier charger to the battery because they're wired in parallel. Okay, so what are the questions to ask when you're selecting a UPS? Essentially, how many watts of power does the equipment consume? So you would get your wattage information on each piece of equipment, add it up, and then that would be your total load. How many minutes of backup time is needed? That's really going to be, up to the end user. And then what's the voltage of the equipment? We see 120 and 208 all the time. It just depends on the application. And then what's the application and the environment? Most UPS systems are designed to be used indoors in a climate-controlled environment. So that's going to actually have a great effect on the life expectancy of the UPS system. Hopefully this training has been a help. For more information, please visit orionpowersystems.com and you can download a catalog from there. And also feel free to call at 877-385-1654 and subscribe to our channel. We're always updating new videos and new techniques for protecting your equipment.